Hi everybody, this is our first video lesson. We'll see how it goes. Today we're learning about how KEQ and the concept of equilibrium can be incorporated into the ideas of Bronsted-Lowry acids. So that's pretty important. We are going to check and see how KEQ can be brought into this kind of stuff. So let's have a look. We are going to first start off by looking at an equilibrium equation, the reaction of hydrogen sulfide with ammonia. And I'd like you to take a moment. We're going to pause the video in just a second, but while we pause it, I would like you to write down the equilibrium equation for these two things reacting. So these are your reactants, and the question is, what are the products? And remember that it's an equilibrium reaction. So figure out which one acts as the acid, which one acts as the base, and then figure out their conjugates and put that as the products, and that's how you would figure out the EQ equation. So let's see if anybody can do it, and I'll give you just a couple of minutes. We'll pause the video now. Okay. So hopefully that after that, if you actually did it and actually paused the video, you would be able to get something along the lines of this, where the hydrogen sulfide and the ammonia, as you can see, react to form these two products. So the ammonium ion and the I don't know what that's called. This one. Anyways, so there you have the reactants and the products. Notice they're in equilibrium. And then if we were to go ahead and label these, it would be called, they would be labeled like this, where the acid in this case is the H2S, and because it's donating the proton, you can see, and the base is NH3, it is accepting a proton. And so in this equilibria, you have two acids, one on the reactant side and one on the product side. And you also have two bases, but we're going to ignore those for now. So the trick to equilibrium and these acids is we're going to ask ourselves a question: which direction does this reaction get pushed more to? Does it get pushed more to the left or more to the right? And can we make a prediction about it? And what does that look like? So we're going to go ahead and take a look at that. So what I want you to do is think about these acids as if they were alive. And I want you to look at the relative strength of this H2S acid and this NH4 acid, okay? Because these two acids are going to compete for to donate their proton. They are like fighting against each other, because as you can see, when this one donates its proton, it is going to push the reaction this way. And then this guy right here is like, hey, wait a minute, but I'm an acid, I want to donate a proton, and when it does that, it's going to push the reaction that way. So these two acids kind of fight over who gets to be the stronger acid. And of course, just like in a tug of war, but it's kind of like a push of war, the stronger acid is going to win. So they compete, that's great, and the stronger of the two acids will be more successful. So what that's going to mean is, if this was the stronger acid, it would push it to the left more, and so this side would be favored by the equilibrium. If this H2S acid is stronger, it's going to push it to the right more, and the equilibrium will hang out more over here in the products. So knowing that, the side of the stronger acid is never going to be favored. The equilibrium will always favor the weaker acid. It says that at the bottom of page 130 if you have a look in your textbook. It has it in bold down there. The weaker acid is always going to be on the side that's favored because of the acids competing to donate protons. Okay, so if we want to take this above example and have proof, all we need to do is take this and write out the KEQ equation from it. So down here we have the KEQ equation of this above example. So you can see that the products are here on top and the reactants are down there on the bottom. And what we're going to do is end up writing a Ka expression for both acids and see how they can be combined. So we're going to write out a Ka expression for each acid and then combine those Ka expressions together, and it's going to be this, the same as this KEQ. Okay, so we'll take a look at that. So in this equilibrium, what we're going to do is say that the KEQ for this equilibrium is actually this. It's the Ka for the reactant acid on the top and the Ka for the product acid on the bottom. So when you write those or find those in the chart of Kas, then you can just copy them out. So we look up H2S and we look up NH4 and just copy those numbers out here and here. Of course, you do the math there, and it comes out to 1.6 times 10 to the negative, or sorry, not negative, 10 to the positive 2. So you look at this. This is a KEQ value, and so it is, of course, larger than 1. Right, and so you can see that because it's larger than 1, that the products are favored because of that rule. Anything larger than 1, it favors the products, right, because it's a ratio. And so KEQ is greater than 1. We can use the Kas up here instead of the KEQ in order to do it. The Kas up here instead of using the KEQ expression. So without even knowing any concentrations, you can calculate your own KEQ of any reaction that you want based on the Ka values. You just look up the Ka values here from the table, put them in this formula here where the reactant acid is on top and the product is on the bottom. Now you got to watch out because these are reversed, right? This is not like it's the reactant acid on the top and the product acid on the bottom. You're used to having KEQ where the products are on top and the reactants are on the bottom, but this is reversed. So make sure that you get that right. Okay, so the reactants go on top when you're comparing the Kas. So the KEQ is greater than 1. Products are favored, which shows that yes, again, the weaker acid is on the favored side. So here are the exercises for the day, 38 to 46. Those are on page, where are we? Page 133. And again, the textbook has a little bit of extra detail if you want to check out or have a question about anything that I said. Thanks. Bye-bye.